Hello students, welcome back to the classroom point. In our today's class, we are going to discuss the electromagnetic spectrum and wave characteristics. So let's begin the class now. Electromagnetic radiation and electromagnetic spectrum, both we shall discuss. First of all, let us have the small idea about what is electromagnetic radiation and how the electric and magnetic fields are generated together. According to the James Maxwell, whenever a charged particle is under acceleration, it continuously transmits both electric and magnetic fields alternatively. So alternating electric and magnetic fields are generated and they transmitted. And you must remember that the source of both electric and magnetic fields is same, but their propagation is in the same direction. So how these electric and magnetic fields are actually present? So let's have the small diagram. So when you take, this is an x-axis, this is an z-axis, and this is a y-axis. See, imagine electric fields are generated like this. And magnetic fields arrange perpendicular to electric fields. Like this. So here, this is an electric field. Let us imagine. And this is magnetic field. Then what could be the angle between the both electric field and magnetic field? Means they are perpendicular to each other, so that the angle is always equals to 90 degrees. How they are generating means, see, the electric fields are moving up and down like this, and the magnetic fields are moving just like a movement of the snake. Snake goes side by side. So that electric fields are moving like this and magnetic fields are moving like this, so they are perpendicular to each other, 90 degrees angle they make. So their source of generation is same and they are moving, that means their propagation is also in the same direction. So both electric and magnetic fields are having the wave characteristics. So let's have what are the characteristics of the wave? Characteristics of wave. So let's draw the diagram of the wave first. So imagine the wave is like this. This is called the equilibrium position or the center. This side, let us imagine positive side, and this is called the negative side. The positive displacement of the wave is known as the crest. And the negative side displacement of the wave is known as the trough. You must remember that the extent of deviation towards positive side must be equals to the extent of the deviation towards the negative side. That means the height of the crest is always equals to the height of the trough. Now let us see what are the characteristics of the wave. A wave is always having the mainly 5 characteristics. They are wavelength, which is denoted by the symbol lambda. Second one is frequency, denoted by the symbol nu. Wave number, denoted by the symbol nu bar. Velocity of the wave, denoted by the letter C. And amplitude, which is denoted by the letter A. So let's have the discussion about each and every of these terms. So let's have the first one is wavelength. So what is a wave first of all? A complete wave always contains one complete crest and one complete trough. So the length of one complete crest and one complete trough is known as the wavelength. See, from here to here one complete crest is over, and from here to here one complete trough is over. So this length is known as the wavelength. So you have to take the one complete crest and one complete trough, or else you can take in another direction also. In another way, if you take the two crests, so the distance between the two successive crests or the distance between the two successive troughs is also known as the wavelength. So here distance between the two successive crests where we are cutting them actually equal parts, making them into equal parts. So here you see this much crest we have taken to calculate the wavelength, and this much we left. So this much crest, whatever we left, we added here. So that's why it becomes the complete crest. If you take the troughs here, from here to here, see here crest is there completely, then trough half of the part we are taking from here and remaining half of the part we are taking from here. And you must remember that whatever the height of the crest and depth of the troughs are there, they remain same as long as this wave is moving, unless there is a change in medium. If they are moving in the same medium, means they maintain the same height of the crest and same depth of the trough. That's why we can measure the wavelength by taking at any part of the wave like this successive distance between the two successive crests or the successive troughs. So that we can write down that, or it is the distance or it is the length between two successive crests or two successive troughs is known as the wavelength. So that it is denoted by the letter lambda. Then what are the units? Units always length units only. So SI units of the length, we know that it is meters. But usually while calculating the waves, their length, we use the smaller quantities. That's why meters we don't take, we take the other terms. But anyhow, those terms always we used to convert into the meters. So usually we consider the angstroms. So 1 angstrom is equals to 10 power minus 8 centimeters. We know that 1 centimeter is equals to 10 power minus 2 meters. So that this value is substituted here. So that now 1 angstrom is equals to 10 power minus 8 centimeters. That equals to 10 power minus 10 meters. And also we know that 1 meter is equals to 10 power 9 nanometers. So that here in the place of the meter you can substitute the 10 power 9. So final value could become equals to the 1 angstrom equals to 10 power minus 8 centimeters. That equals to 10 power minus 10 meters. That equals to 10 power minus 1 nanometers. Sometimes people calculate the length of the wave even in the picometers also. So 1 picometer, usually this is represented as 1 pm, equals 10 power minus 12 meters. This is about the wavelength. Now let us discuss about the frequency. What is the meaning of the frequency? Usually the word frequency is used to define any particular thing if it is repeatedly happening. If any particular thing is happening repeatedly, so there we use the word frequency. For example, imagine there are 3 persons, A, B and C. There is a room in a particular office. Imagine a person is going to the room and coming back to his position within 1 hour. Almost he is traveling 100 times. And person B is going to the same room or another room in 1 hour. The person is traveling almost, making the rounds almost 50. Whereas C person is going but is making only 30 rounds. So who is making more rounds here? A. So that the frequency of the movement of the A person is more than the B, B is more than the C. So when it applied to the wave, then here we have taken the fixed room, here we have taken the fixed point. So while taking the fixed point, just imagine the number of waves that can pass through a fixed point in 1 second of the time is known as the frequency. So here number of waves, wave means, as I said, one complete crest, one complete trough. If you cut this trough and add here, it becomes like a cycle. So one wave is nothing but the one cycle, we can consider it. So here if the number of waves that can pass through the fixed point, as we said, is known as the frequency. See, this is the one particular A wave and another wave is there. This is B wave. Next C wave is there. So A wave only one cycle passed. Means only one wave passed through the fixed point in 1 second of the time. Whereas B wave, 2 cycles passed. Means 2 waves passed. In case of the C wave, 3 waves are passed. One wave is nothing but the one cycle. So here we can say that in 1 second of the time, 1 cycle per second passed through the fixed point. Here 2 cycles per second passed through the same fixed point. And here 3 cycles per second passed through the fixed point. So where frequency is more, wherever more waves are passed through the fixed point in a given time, that is known as the frequency. So here frequency of the C wave is more than the frequency of the B, which is more than the frequency of the A. So nowadays this cycles per second is completely replaced by the new term, that is hertz. So 1 hertz is equals to 1 cycle per second. Anyhow, cycle is not the unit, it is representing the wave. So here only second per second we are taking, so that 1 hertz is equals to 1 per second. This is the frequency. Now let us see what is the relation between the frequency and the wavelength. If you observe these 3 types of the waves, A, B and C. A is making only one wave, means one cycle. See, the wavelength of the A is this much. It is going through the fixed point. Whereas B wave, 2 cycles per second. See, B wave is going like this. So here if you see the wavelength of the A, this much is present. And in the case of the B, the wavelength is this much. And if you take the C wave, 3 cycles per second it is moving. But here wavelength of the C wave is very small. So whose wavelength is more here? Wavelength of A is more than the wavelength of the B, which is more than the wavelength of the C. When in terms of the frequency of A is less. In terms of the wavelength of the A is more. That means both frequency and wavelength are inversely related. So that we can relate this both frequency and wavelength using the formula nu is inversely proportional to the lambda. So by replacing this proportional symbol, we can use the one constant. That constant nu equals to C upon lambda, where C equals to velocity of light. Why we have taken only velocity of the light as the constant? Why? Because velocity of the light is always remains constant, and light also moves in the form of the wave. That's why we have taken the velocity of the light. Now let us see the other characteristics of the wave, that is remaining parts, wave number and velocity, amplitude. Wave number is denoted by the symbol nu bar. So wave number means the number of waves. The number of waves present in an unit length is called wave number, or else it is the reciprocal of wavelength. So similar concept, let's take here. This is the unit length. Imagine 1 centimeter distance. So let us take different waves. A, this is B, now this is C. See here, how many waves are present? See, this is one cycle up to here. This is again remaining. Let us consider complete cycle is over. So 2 cycles are present. Here you have to count. See, this is 1, this complete crest, complete trough. So 1, this is 2, 3, like this. You have to count. Here also, if we count, the number of the waves present in the case of the C is more than the B, B is more than the A. So number of waves. Number of waves, where it is more, C has more number of waves than the B, B is having more number of waves than the A. Why C is having more number of waves than the B, B is having the more than the C? Why? Because in case of the A, the wave is completely stretched. Since wave is completely stretched, less number of cycles are possible in the given unit length. That's why one crest, one trough, again one crest is over within this unit length only. That means when the wave is stretched, length increases, so that number of waves that can be accommodated in a unit length decreases. See, this much is the unit wavelength for the A, and here wavelength is this much, and here wavelength is this much. So that when the wavelength decreases, you can place more number of the waves in an unit length. That's why wave number is the reciprocal of the wavelength. When the wavelength is less, wave number will be more. So that nu bar is equals to 1 upon lambda. Then what are the units of the nu bar here? So units of the nu bar is nothing but the lambda units. Already we have seen that is meters. So 1 upon meters, that means per meters, are the units of the wave number. Then how this wave number and frequency wavelength are related? So let us see here. You know that frequency is equals to C upon lambda. This can be written as C into 1 upon lambda. 1 upon lambda means nu bar. So that nu equals to C nu bar. So like this we can write down the relation between the frequency and the wave number. Now let us see the velocity and amplitude. Velocity of light or velocity of the electromagnetic waves. So what does it mean by velocity? It is the distance covered by a wave in a second of time. I am taking second of time, you can take any unit time. Second of time is known as its velocity. Usually velocity of the light or all electromagnetic radiations we take as 3 into 10 power 8 meters per second, or else we can take the 3 into 10 power 10 centimeters per second. You must remember that all electromagnetic radiations travel with equal velocity. So that here all electromagnetic radiations travel with equal velocity. That means velocity of the light or velocity of the electromagnetic radiation is always constant. Since it is constant, it is not depending on the either frequency or wavelength of the electromagnetic radiations. Whatever it may be, it travels with the same velocity. And remember that these electromagnetic radiations do not require any of the medium for their propagation. So they can travel even in the vacuum also. But sound waves means if you are listening to my words, so that it has to reach from here to there. So here it needs some medium. If you go to the vacuum place and if you try to speak something, but those words cannot reach to the other side person because the medium is not there. But light doesn't require any medium for its propagation. Even it can travel in the vacuum also. So next one is amplitude. Amplitude is denoted by the letter capital A. So as I said earlier, amplitude means the maximum displacement of the wave from its equilibrium position or the center position or from the origin. You can take any of these. So the maximum displacement of the wave either towards the positive side or towards the negative side is called as its amplitude. So if you take the height of the crust, the maximum height of the crust is known as the amplitude A, or the maximum depth of the trough is known as the amplitude. So it is the maximum height of crest or depth of the trough. So that is what called the amplitude. Then what are the uses of amplitude? When the height of the crust increases, then automatically wave value also increases. Value in the sense, wave consists of the small particles of the energy. That's why energy of the wave also increases, brightness increases, and intensity also increases. So that amplitude stands for or refers the more the amplitude, more will be the both intensity and brightness. Then how this energy of the wave is related to the amplitude means energy of the wave is directly proportional to the square of the amplitude, A square. That means here amplitude is directly related to the energy. Higher the amplitude, more will be the energy and more will be the brightness of the light. And if you see the two type of the lights, where one light is a dim and one light is the bright, then we can say that the bright light is having the higher amplitude light, whereas the dim light is having the lower amplitude lights or waves. Now let us see how many type of the electromagnetic radiations are there and how we can segregate them. So still now we discussed about the characteristics of the wave, that is wavelength, frequency, wave number, velocity and amplitude. Here both amplitude and velocity except these three remaining all depends on the type of the waves. So when the wave changes, different type of the electromagnetic radiations are having the different type of the frequencies and the wavelength. So all electromagnetic radiations are not having the same type of the frequency and wave number. So based on that, electromagnetic radiations have been classified into various categories. So let us see them. They are cosmic rays, gamma rays, X-rays, ultraviolet rays, visible radiation, infrared radiation, microwaves and radio waves. So based on the various ranges of the both frequency and wavelength, electromagnetic radiations have been classified like this. So these radiations are arranged in the decreasing order of their frequency. That means cosmic rays frequency is very high, whereas if you go to the radio waves, frequency is very less. So these are arranged in the decreasing order of their frequency, or else we can take the increasing order of their wavelength. So that if wavelength wise if you take, you know that nu is inversely proportional to the lambda. So frequency is high means automatically wavelength is very less. So here wavelength is less and here wavelength is more. So the arrangement of the various type of electromagnetic radiations in the decreasing order of their frequency or increasing order of their wavelength is known as the spectrum. So that arrangement which gives a photographical representation, that is what called the spectrum. And here there is a particular part of the spectrum which is visible to our naked eye, that is what called the visible spectrum. So this visible one is having range 400 nanometers to the 750 nanometers. Only this much range of the electromagnetic radiation we can see directly with our naked eye. Rest of the waves we cannot see. And this visible spectrum is having the 7 colors. They are violet, indigo, blue, green, yellow, orange, red. You must remember that as long as these 7 colors are combined together, they stay together, it appears like a white color. So whatever the color of the light we see, natural light, it is a combination of the 7 colors. What are those? These are the 7 colors: violet, indigo, blue, green, yellow, orange and red. When this white color is passed through the prism, nickel prism, so that prism can separate these lights into various categories. Here we can get again arrangement of these colors: violet, indigo, blue, green, yellow, orange, red. So this arrangement of the lights, whatever the radiations are there, all these we can get in the photographic plate. That is what called as again spectrum. So that the arrangement of the various type of electromagnetic radiations on a photographic plate is known as the electromagnetic spectrum. I hope you understand this class, and we shall meet in the next class. Thank you all and all.